So with a reminder on what angles are, we're going to talk about our two main units for describing them, degrees and radians, where degrees are probably what you're more familiar with as a measure of rotation, as the measure of an angle, as we are taking the value strictly in terms of an amount of spin with the unit notated by that little circle there, where we're going from 0 to 360 for one full rotation to end up, in essence, back where you start. And that's where most of the work we deal with goes, but technically speaking, you could keep going from 360 past to 720 for a second spin, and then onwards from there up to 1080 and beyond, but I can already feel myself leaning and the floor is spinning a little bit. So while I would advise against illustrating rotation manually, you should get the idea of how it works, where radians are a similar sort of idea, except instead of talking about rotation as a somewhat floating concept, we talk about it in terms of the relation between the arc length along a circular path that the angle can be seen as tracing and the radius of the circle that path generates. Where this idea of connecting the radius and the arc length is actually kind of an old one to my research. There's evidence of a similar construction dated back to Persia in the 15th century. And from there, the idea specifically of calling it a radian, that term was, or at least is, commonly attributed to James Thomson, a Scottish engineer who would be fairly successful in his own right if not for the fact that he is the elder brother of Lord Kelvin. And you can only imagine how frustrating that must have been to be so thoroughly overshadowed not just by your younger brother, but by your younger brother in essentially the same field. I guess that makes Thomson the Donnie Wahlberg of Scottish mathematicians. I say that knowing that that's a dated reference even for me. New Kids on the Block was popular before I was born. I guess he's been in some good movies too, but... Anyway, we're going to talk about, going back to this mathematical construct, is how we can measure our values of spin, our angles as it were. We have a few special cases that you should be familiar with, where we call an angle with measure between 0 and 90 degrees, or 0 and pi over 2 radians acute. A right angle is one of specifically 90 degrees, or pi over 2, or pi halves, as some people prefer to say, radians. Obtuse goes between 90 and 180, or pi over 2 and pi. And then finally, a straight angle has a measure of 180 degrees, or pi radians. Where this idea of using pi in this way dates back even further than the discussion specifically of the radian as a unit of measurement. In this case, it's the SI unit of measurement, so even though we're probably more familiar with degrees at this point, we're going to spend most of our time on radians in this class. We use that notation in particular to recall the idea of pi being the Greek letter representation for the circumference of a circle in relation to its diameter. So, if we want to discuss the connection between degrees and radians as a measurement, well, we have to understand how we can measure certain angles. For example, if we want to talk about that full rotation, we had that 360 degrees is a measurement of a full spin, which I'm not going to do again because I don't want to make myself dizzy. On the other hand, if we want to think about what that represents, well, that's a whole run around a circle, as it were. So if we want to talk about it in terms of radians, we would have 2 pi r for the whole circumference of the circle divided by r, because the radians are measured in terms of the length over the radius, the ratio between the arc length, here the whole circle, and the radius of the circle, which we're just saying is r. So 360 degrees is equal to 2 pi radians. And this gives us the basis for our conversion between these two values, but we can take it a step further and say that 180 degrees is equal to pi radians. Which, okay, that's fine. We kind of said that already. But from here, we can do something creative and important that most people don't like to do, but is a very important trick in math. We can rewrite 1 in a couple of very important ways. We can say that 1 is equal to either pi radians, which I'm going to abbreviate pi rad because obviously pi is very cool, divided by 180 degrees. Or we can say that 180 degrees over pi radians is equal to 1. And that doesn't seem to do anything. Technically it doesn't. But what this allows us to do is get a useful and quick way to convert from degrees to radians or radians to degrees, which we'll see with a couple of examples next.